Amounts of components in a mixture, we use what are called concentration units. So the concentration units can be parts per 100, parts per million, parts per billion. There's also percent by mass and percent by volume. And there's molarity, which we'll get into in a later chapter. But these concentration terms are used for dilute and low concentrations, which is the case for pollutants, air pollutants or water pollutants. They are not in high concentrations, and so it's something like 1 part in 100 in your total mixture, or 1 part in your total mixture having 1,000,000 parts, or 1 part in your total mixture having 1,000,000,000 parts. Okay, and so this parts per 100 is an example is that we have 78% nitrogen in the atmosphere and 21% oxygen in the atmosphere. So parts per 100 means the 21 of that component, oxygen, O2, in the mixture, which has 100 molecules. So that's 21 in 100. So that's percent is parts per 100. Okay, and percent you're pretty familiar with from percents in grading. Like 90% is an A, it's 90 out of 100. So parts per million and parts per billion are more commonly used for air pollutants. And so we'll see those units attached to air pollutants. We'll see them attached to water pollutants in Chapter 8. And we'll also see them attached to these units attached to this parts per million in particular is carbon dioxide in the atmosphere. Atmospheric carbon dioxide is typically reported in parts per million. Parts per billion are used for air pollutants and water pollutants. So those are low concentration. That's what we would desire for pollutants. So if you see a number where you have ozone, which again is O3, the chemical formula, this is a number value reported as 0.4 ppm. What that means is that there are 0.4 of those parts, the ozone molecules, in the total mixture that has 1,000,000, which is 10 to the 6 molecules. Okay, so 1,000,000 is 10 to the 6th. And that's what the M in ppm stands for, is how many parts in 10 to the 6th in 1,000,000. So for even more dilute concentrations, lower concentrations, like the sulfur dioxide, this is an air pollutant. This is the standard, an air quality standard, that the sulfur dioxide in the air should not exceed 30 ppb. So ppb stands for parts per billion, and a billion is 10 to the 9. Okay, so this 30 ppb means that there are 30 parts in the total mixture that has 10 to the 9, a billion parts. So 21% means parts per 100. Percent is parts per 100. And we can do these conversions to percent and parts per million, ppm, or even parts per billion. The number 21 doesn't change, but this fraction will change. So if we were to do this stepwise, 21% means you have 21 in 100. Okay, so if you were to, let's actually put it over here, 21 parts in 100 is parts per 100, 21%. So let's take this stepwise to get to how many parts per million. So stepwise, I'm just going to multiply times 10 each step. So times 10 would be not 21, but 210. And parts per 1,000, this would be 210 parts in 100 times 10, or 1,000. Okay, multiplying again by 10, this would be multiplying this to 10 by another 10, so you would add another 0 to it, 2100 parts in 1000 times 10, which would be 10,000 at this point. Okay, adding decimals there. Multiplying this by 10 again is going to be not 2100, but add another 0, 21,000 parts, and multiply this, and this is 10,000 times 10 would get you to 100,000. So that's going to be 5 zeros after there. And then multiply times 10 again, and this would be 210,000 parts. In this would be a 1 now with 6 zeros after it. That's a million. And so that was the goal, to try to get from percent to parts per million. Okay, if we could continue on to parts per billion by just multiply 10 and 10 on both the parts and the total, but this is 21% is equal to 210,000 ppm, parts per million. So the difference between the percent and parts per million is a factor of 10,000. This is times 10 to the 4. I multiplied 10, 10, 10, 10 to the 4. And this is why when you have a low concentration, you would not have 21%, you'd have like 0.00021%. It's more preferable to have this represented in parts per million, and then you don't have to have all those zeros. 21% is a higher concentration, and it's preferable to represent this in percent because now we don't have all those zeros. We'll review these concentration terms, percent, parts per million, and parts per billion, in this worksheet during the lecture time. But this is a quick review in this box that percent is parts per 100. And so if you have something that's 3%, it's 3 in 100 parts. Okay? And so another way to think of that is not just 3 in 100, but 3 in 10 squared. Okay? Parts per million is how many in 10 to the 6. So 3 ppm would be 3 in 10 to the 6, which represents the million. And ppb is parts per billion. A billion, remember, is 10 to the 9. So the value 3 ppb is 3 parts in 10 to the 9, the billion. So working with the exponents instead of those zeros. Okay, so we know that parts per million works with less concentrated, low concentrations, and lower concentrations than percent. And then we know that parts per billion is even lower concentration than parts per million. Okay, or you could also say that this percent is more concentrated than parts per million, or parts per million is more concentrated than parts per billion. So it's important to understand which is bigger, percent, parts per billion, because when you are converting between these units, the number doesn't change, 3, 3, 3, but what your understanding of is the mixture is going to help you understand which direction to go as far as increasing by tens or decreasing by tens.